session. It's a the protocol for routing. So this chapter is most important as far as the whole 5 modules are concerned. And initially, what we had seen in MAC protocol, those were comparatively easy things. So suddenly there is a increase in the difficulty level, and you will find these protocols for routing are quite complex, and this chapter what I find is little critical to understand. So all the protocols and all you have to understand quite clearly, and third chapter onwards things will become again easy like it was in the chapter number 1. So we had seen initially what is meant by routing and what are the design issues of routing, and after that there is a very important concept we will start today, that is the power aware routing protocol. So I told you in ad hoc network there are mainly 3 issues. First issue is all the nodes are mobile, so continuously nodes are moving here and there. So there is a very highly dynamic topology in the network. So because of that, the path break can occur, and if path break occurs, then routing protocol will not be maintained. So that is one thing. Second problem is the whole ad hoc network is too much of bandwidth constraint. That means there is a shortage of bandwidth for every node. So whatever data transmission has to be done, that has to be done in a very properly planned manner. Otherwise, too much data if we want to transmit through a very small bandwidth, it might take a lot of time and it might jam the whole network. So that is a problem. So bandwidth constant is a problem. Then first I told you that mobility is a problem. Third problem in any ad hoc network is the energy or power. So power or energy is used in the same line here, so there is nothing to confuse as such. So energy in any sensor node or power in any sensor node is supplied by a battery in the sensor node, and that battery is not too big. That battery is actually small. Okay, and that battery has to transmit power for sensing. That battery has to give power for sensing, give power for microcontroller application, for transmitter, receiver, and if there is any movement of the node, that power also will come from the battery. So the energy source in every node is very minimal, but the node has to do a lot of work. Okay, that's why every node there will be a scarcity or shortage of power, or whatever power or energy you are having at every node, you should be able to use it very properly in a very planned manner. So first topic today, it says that power aware routing protocol. So how can we save some kind of power inside that node or inside that battery by properly planned routing protocol? So routing protocol has to be in such a way that unnecessary transmission of power, unnecessary reception of power, too much of control packet transfer. So I told you there are mainly 2 packets, RTS, CTS, acknowledgement. All those things are actually control packet. They are not carrying directly any data or signal, but they are actually required to set up the communication path, or to set up the route. So they are called actually control packet, and there is data packet. So for transmission of control packet also, some amount of bandwidth are being wasted. So too much transmission of control packet has to be reduced. That way we can save the power. So first topic today will be power aware routing protocol. How routing protocol saves some sensor node power. Why to save sensor node power? So if you are saving some sensor node power, in contrary, that is going to keep the sensor node alive or active for a longer period of time. If the sensor node is alive or active for a longer period of time, that means the network will be active for a longer period of time. So this is the main agenda. So saving the node power will keep the sensor node active for longer period of time. And if the node is active for longer period of time, means the network will be active for longer period of time. So this is the main reason why we want to save power at every stage of or for every act of the routing protocol, or for every act of the ad hoc sensor network. Second topic, actually clustering I have brought here because some of the fundamentals of clustering will require in case of next topics, that is multicast routing and all. But clustering is not a topic of this chapter. Clustering actually is there in chapter number 4. But then also some basic introduction of clustering we will see at this chapter only. So I'll give you a basic introduction of what is meant by sensor node clustering, and then we will see what is meant by multicast routing. So most important part of this chapter is multicast routing in ad hoc wireless network. An introduction to multicast routing I will give you today. Okay, so I'll start with the first power aware routing protocol. A very important question for 5 marks, that what are the metrics of power aware routing? Metrics means what are the main parameters or what are the main measuring parameters of power aware routing protocol. That means through routing protocol also we have to save some network power. Our routing protocols should be in such a way that it is not wasting much power for routing. Okay, that is the main agenda. And what are the main metrics? What are the main measurement parameters for that? That we will see. So very important question, that is explain what are the metrics of power aware routing protocol. There are 5 metrics. All those metrics I have shown here. You have to explain very clearly. So these are the topics. I told you that this chapter is divided into mainly 2 parts. So this first part is actually different types of routing protocols. So initially we have seen a routing protocol, that is table based routing protocol we have seen, and then fish eye type of hierarchical routing protocol we have seen, and then we have entered the topic of multicast routing. So during multicast routing, we will see what are the different types of multicast routing. But wherever we finished yesterday, so last day actually we had done 2 protocols. One is DSDV, another is fish eye. Today we are going to do another protocol, only the metrics of that, that is called as power aware routing protocol. So if you are doing this 3, DSDV, fish eye and power aware, that is the initial protocols of routing. And then we will see what is clustering. Again, I am telling you this is not a topic of this chapter, but to understand multicast routing and other things, we should know what is meant by clustering. So this word will keep on coming. So after power over routing, we will see clustering, and then we will see the introduction to multicast routing. What are the design issues? What are the initial things? Classification of multicast we will see next. So this is mainly the flow of the initial part. So this chapter is divided into 2 parts. First part is routing protocol, and second part is TCP. So you are already studying TCP in some other subjects. So TCP in ad hoc, that will be the second part of this chapter. Okay, so we are still in the first part of this chapter, and before IEA, I will try to finish off this first part of this chapter. So today I am coming to lectures. Target will be to finish off this first part of this chapter or module number 2. So this was the classification. So first there was the based on routing information update mechanism. So there was the proactive or table driven routing protocol, DSDV. This is in syllabus. Then there is based on routing topology. So how the routing topology is affecting. So here in fish eye we had seen whichever nodes are very closer to the sender node or one hop distance of the sender node, those informations are updated very fast. Those informations are the very important. Second hop, third hop, second hop node, third hop node, for those nodes information update process is little less frequent, and those informations are not very dynamically being updated. Okay, that is what we have seen in case of fisheye, and we have seen a very small topology of 4 nodes, and we have found out 4 tables. Okay, so that is the way you are supposed to write it. So you can check previous just lecture, you will find it out. Then today we are going to do the power aware routing protocol, actually based on the utilization of specific resources. So there are mainly 2 resources in case of any ad hoc network. First one is bandwidth, second one is energy or power. Okay, so how you are saving the power during routing protocol or node power during routing protocol, that is explained in power aware routing protocol. So here I have already given you the introduction, power aware routing protocol. So it's a 5 marks question mainly. The main 5 metrics are asked in power aware routing protocol. So you have to explain all those 5 points very clearly. So in a deviation from traditional wired network, so there is a wired network and this is wireless ad hoc network. We are always trying to copy all the protocols that is present in wired network into wireless network, and in doing that there is coming some problem. So what is the difference? We will see here. So in deviation from traditional wired network routing and cellular wireless network routing. So first is wired network, then there is cellular network. Cellular network means it is a with infrastructure network. So cellular network is having a centralized access point or base station. Okay, but power consumption by the nodes is a serious factor to be taken into consideration by routing protocol for ad hoc wireless network. So traditional wired network and cellular network, they are not having power consumption issue because both are connected with generator, both are connected with ample amount of power source. So that's why they are saying traditional wired network and cellular network, they are not having power consumption issue, but the nodes of ad hoc sensor network, they are having serious factor. So power consumption is a serious factor for ad hoc wireless sensor network. This is because in ad hoc wireless network, the routers are also equally powered constrained just as the nodes. So sender node, receiver node, and intermediate to sender and receiver, whatever nodes are there, they might be called as repeater nodes, routing nodes, and all these things. So all the nodes are having very constrained power source. The power are not given there forever. So as much as power you can use, it is not like that. So every node is power constrained. Here discussed are some of the important routing metrics. That means from routing point of view, what are the constraints or what are the metrics, measuring parameters we can use that take into consideration the energy factor. So routing has to be in such a way that it will also save some power in ad hoc wireless network. Power over routing metrics. So metric means meter as a standard of measurement. So, okay, so this is a measurement parameter. Here it is given why routing metrics, power over routing metrics are required for ad hoc network. It is said that less availability of operational power is a significant bottleneck. Bottleneck means problem in case of ad hoc wireless network. So given the requirements of portability, weight and size, that is ad hoc network node should be portable, it should be small in weight, it should be small in size. Okay, and it should be commercial. Commercial means it should be less cost. Okay, so all good features we want in case of ad hoc node, but they should be light, they should be small, but they should be highly power efficient, and they should long for quite a longer amount of time. They should last for quite a longer amount of time, and they should be less costly. So too much of different types of requirements we are posing for this kind of ad hoc wireless networks. Okay, so before a route is decided, that means before we are deciding a path for data transmission, the routing matrix considers the power left in any node. So first we see which node wants to send the data. So sender node. To which node it wants to send the data. So that is receiver node. After transmitter and receiver are fixed, then we check which are the intermediate nodes which are full of power or whose battery is having a very high charge already stored in it. So some node if we select in the routing path which is having very less energy in it, in that case during the data transmission that node's battery might get exhausted and data transmission might not get completed. So while selecting the routing path, first we have to check that whatever are the intermediate node, how much power is left in all those nodes. Knowing, so there's a very important term is coming which is called SOC, which is called state of charge. So knowing the state of charge at any node helps in more efficient and better utilization of node energy. So instead of using the same repeater node too many times frequently, let us define different routes for transmitting data from one node to another. So first we have to define which node wants to send the data. So first we have to define which node wants to send the data. Hello, is it audible and visible? Somebody please respond. Okay, so there was a power failure. I'm sorry, intermediate, there was an interruption. Okay, I'll resume then. Okay, so knowing the state of the charge, knowing how much power is left in any of the sensor nodes at any time, that helps in more efficient and better utilization of the node energy. Okay, so we should know how much power is left in whichever nodes, and whichever nodes are carrying more power, having higher state of the charge, those nodes we will keep in our route. And the nodes which are having very less charge, only 10% of the battery is remaining or already exhausted battery, we will not take all those nodes in the path. So this in turn helps. So this line, this black lines are very important. Knowing the state of the charge at any node helps in more efficient and better utilization of node energy. This in turn helps the node and the network lifetime. So node lifetime increases means node will be active for longer period of time. That will increase the network lifetime. So this in turn helps to increase the node and network lifetime. Many routing metrics are proposed in papers that supports conversion of battery power. So the routing protocols that select paths as to conserve power must be aware the SOC of the battery. So at any time within the network, we should know which are the nodes and how much of the energy is pending in all those nodes. So every node, how much is the energy pending in that node, we should be able to understand at any time. So what are the simple things that at the given node, how much is the SOC present, and at the other intermediate nodes in the path. So from the sender to the receiver and intermediate nodes at any time, how much is the state of the charge pending or how much is the energy pending. This is the main parameter that we have to check while we are deciding a routing path. Now come to the main important question. What are the 5 design metrics? So in exam, if it is asked, you have to explain these 5 points. First point is minimal energy consumption per packet. That means from the sender to the receiver, whenever a node is traversing, so traversing means packet. Whenever a packet is traversing or traveling from the source to the destination, it should consume minimum energy. That means for reception of the power, for reception of the packet also the node has to waste some energy. For transmission of the same packet from one node to the other, there also some transmission energy has to be given. So the packet, any packet, data packet from the sender to the receiver, it should be costing least amount of energy to the network. That is the agenda. So energy consumed by a packet when traversing or traveling through a path is the sum of energies required at every intermediate hop. Every intermediate hop means the sender node is transmitting that data packet from the sender to the next node. So for that, whatever is energy required, that should be least. And whenever a receiver node is receiving that packet, there also some energy has to be given to receive the packet. So this transmission energy plus receiving energy at every hop, that means every jump of data packet, should be as less as possible. More than that, energy consumed at any intermediate hop is a function of distance between all the nodes. So more is the distance, more will be the transmission and reception energy. And not only the distance, the busyness, the data on that load link is also very important. So if a link is carrying data from some 2-3 different senders and receivers, in that case for same jump it will be costing more energy. Okay, so one sender and receiver or one pair of nodes carrying only one type of transmission, then energy will be less. But when the same transmitter and receiver, the same 2 nodes are carrying 3-4 different types of communication, then for the same packet more energy will be required, because in that case there comes different things, because security of the data also has to be maintained. So that's why the data load on the link is also another factor. That means the link is heavily busy or underloaded or properly loaded. That thing also decides how much will be the transmission power and reception power for any data packet. So this metric, that is minimum energy consumption per packet, does not balance the load so that uniform consumption of power is maintained throughout the network. What is meant by balancing the load? Distributing the load over all the intermediate nodes in the network. That is what is called as balancing the load. That means do not, if there are 3 different paths from the sender to the receiver, don't repeatedly use only one path. In that case, all the nodes in that path get exhausted. So use all the three paths equally over equal time. So share the same load equally among all the three different paths. So that is called as load balancing. So this metric does not balance the load so that uniform consumption of power is maintained throughout the network. So this minimal energy, it will be minimal energy will be achieved if the data packet load is shared over all the paths between sender to the receiver. But it does not happen because this disadvantage of this metric include, that is minimal energy consumption. This is having a disadvantage. Selection of paths with large hop length. That means if the distance between the sender and receiver is too much big, in that case every data packet transmission will cause more power from the transmitter and receiver. Inability to measure the power consumption at a link in advance when the load varies. Suppose suddenly the load is increasing or decreasing. In that case, the sensor node should be smart enough to calculate or estimate how much will be the power required to transmit this variable data from the sender to the receiver. That means whenever we are starting journey, I'm just giving an example of a car. So whenever we are starting journey from the transmitter to the receiver, that is from the source to the destination, we should be able to fill the tank of our car in such a way that we should be able to make the full journey. But we don't know that if maybe there will come some disturbances in the path, maybe we have to reroute our car in between. So in that case, what might happen is the petrol tank might get exhausted. So the same thing is there. Inability to measure the power consumption at a link. Link is nothing but the distance of the path. Okay, in advance when the load varies. So if there comes more pressure, so if you want to keep your AC on throughout the journey, in that case for the same distance, the amount of petrol spent will be more. Okay, so the same thing that the node should be able to calculate how much will be the energy required for any dynamic situation between the source to the receiver. That does not happen. If it does not happen, then it is difficult for minimal energy consumption per packet. We cannot be able to cost minimal energy. In that case, energy wastage will be more. Inability to prevent fast discharging of batteries at overutilized node. So again, I'm telling you, do not use the same node repeatedly. If one central node is used repeatedly, what happens, that will get discharged very fast and the main path between transmitter and receiver will be broken. So instead of using the same path repeatedly, distribute the load or distribute the data transmission from sender to the receiver through different paths. Okay, this is all the things given in the first point. So try to analyze all this point, read it repeatedly 1 or 2 times, you will understand what exactly it is saying. So first was minimizing the energy consumption per packet. Second is maximizing the network connectivity. The matrix or this characteristic, matrix means measuring characteristic, attempts to balance the routing load among the cut set. So that means initial input side there is a set of node, output side there is a set of node. So the whole network topology, if they are having 30 different nodes between transmitter and receiver, you can cluster them. So you can have a cut set of the whole node. So 5, 10 sensor nodes together, one set you can form. And you have to see that in every such set or subset or cut set, the connectivity is maximized. That means the data transmission reception connectivity is very high. So this metric attempts to balance the routing load among the cut set. That means within a small set, you see that, or we decide that all the nodes will be utilized properly. Not that on one node huge data transmission load will come and few nodes will be left aside. They will not be used at all. Okay, so every node should be given equal amount of job. That is what this matrix means. So this matrix is going to balance the routing load among all the cut sets of the node, removal of which results in network partitions. So some node repeatedly we are using, that node will die and that will create a partition between two sides of that dead node. This assumes significance in environments where network connectivity is to be ensured by uniformly distributing the routing load among the cut set. It means that everybody in a team should be doing its own work properly and equally. It's not that among 1 or 2 nodes the main data transmission pressure would come. Okay, with a variable traffic, origination rate and unbounded contention in the network, it is difficult to achieve a uniform battery draining rate for the cut set. See, network always is having a tendency to use the shortest path between the sender and the receiver. And we have done one more thing, that is soft kind of routing. So soft path selection, last we have told that whenever a sender is given some job of sending a data packet from the transmitter to the receiver, it always tries to use the previously used path. Okay, so that is actually the soft kind of path selection. That means whatever has already been used, which path is shortest, which path was used successfully, network would try to use again the same path. So the same path is used repeatedly means all the nodes in that path will drain its energy very fast, and that node will die, and that will create a partition among the whole network. Partition means one side and another side there is no connectivity. So if the central node dies, that means the network is divided into two parts and there is no connectivity between those two nodes. So if there is a connectivity issue, if the node dies because of power, at that time there is created some partition. So such thing should not happen. So only one thing is, every node should be given equal amount of job. So first you have to check how much is the total data transmission load of the network, and we should route the packets in such a way that every node gets to do equal amount of work throughout the data transmission session. Third thing, minimum variance in load power level. So this metric proposes to distribute the load among all nodes. So the same thing is being repeated in the network so that the power consumption pattern remains uniform across them. So if you are distributing the load, that is actually maximizing the connectivity, that is actually minimizing the power usage. So the only word is balancing the load, whichever is the third point. Minimum variance in load power level. Minimum variance means all the variance of work should be as less as possible among all the nodes. That means all the nodes should be doing equal amount of work. Variance means variation. Variation should be less. That means all the nodes should be doing equal amount of work throughout the session. So variance is less means load is balanced. In that case, there will be minimal energy of consumption per packet. In that case, there will be maximized network connectivity. Fourth point is minimum cost per packet. So here cost does not mean money. Here cost means energy cost, and the energy cost should be as less as possible. So to maximize the life of the nodes in a network, which in turn maximizes the network lifetime. So very important line. So node lifetime increases how? By reducing the battery power. So if we reduce the battery power wastage, that will increase the node lifetime. If node lifetime increases, that will maximize the network lifetime. So same network we should be able to use for longer period of time. So this routing metric, that is minimal cost per packet, is made as a function of the state of the node's battery. Node cost means node utility here, not the financial cost. It is node utility, how best you can use a node. Okay, so node cost decreases with decrease in its battery state of charge. So less is the battery remaining in the node, its utility will become less, because in that case, if energy is less in that node, none of the routing path will select that node in the actual routing. So none of the planning will happen with that node keeping in mind. So everybody would try to avoid a node who is having lesser power. So the amount of remaining battery charge at a node is the most important cost factor is used for routing. So for routing, this is the prime or main factor. So we have to first check how much is the energy left in the node. If more energy is left, then only we will take that node for routing. Otherwise, no. From energy discharge pattern of the node battery, the node cost may be computed. So whether it is very fast discharging or slowly discharging means that node will be active for a longer period of time. That will keep the network active for a longer period of time. So from energy discharge pattern of the node battery, the node cost may be computed. This matrix provides a very easy way to calculate the cost factor at any node. That means how important that node is, how much will be the utility of that node. Depends only on one parameter, that is how much is the energy remaining in that node. More is the energy remaining, more will be the cost factor, more will be the utility factor of that node. At the same time, congestion handling at that node may also be done applying this matrix. So if the node is getting congested, then it has to transmit or receive data for a longer period of time. So if a node gets congested, means if it is having higher amount of energy for a longer amount of time, it will be active, and in that case it will be able to solve the congestion problem. Last factor, minimize the maximum node cost. So whatever is the maximum power usage for any node, for any operation, that has to be as less as possible. So this metric minimizes the maximum cost per node. That means whatever is the energy usage per node, they should be as less as possible for packet after routing a number of packets within a specified period. So for routing, timing is also important, that within how much time we are transmitting all the packets through it. So within that period of time, maximum amount of packet has to be transmitted, and for that maximum packet transmission, minimum amount of energy we should be able to use. That is what is the fifth point. See, all these points are very close. As long as you are not reading it repeatedly, you will not be able to understand or get the sense of it. So this metric minimizes the maximum cost per node for a packet after routing a number of packets within a specified period. This delays the failure of a node occurring due to the higher discharge because of packet forwarding. So higher discharge happens when, if the data transmission rate is too high, at that time transmission power, reception power will be wasted in a very faster rate. In that case, discharge will happen very fast. In that case, node will be dead very fast, and network also will die very fast. So we have to do in such a way that by routing protocol, we should be able to minimize or reduce the cost of transmission and reception power, so that the node energy cost factor is maintained, so that we are able to distribute the load among all the nodes in the network, so that we are not unnecessarily pressing or unnecessarily burdening one single node and that node dies first. So if the node dies first, in that case partitioning will happen in the network. If partitioning happens, that means there will be no data transmission from the sender to the receiver. So for proper data transmission over the network for a longer period of time, most important thing is load distribution and distribution of energy cost factor among all the different sender, receiver and repeater node. So this was about power over routing metrics. All these 5 points you have to explain in detail. Then I'll go for clustering. So clustering means just grouping the nodes together by some kind of logic. So if we want to know all the nodes in a sensor network, in that case for every node I have to keep a separate notebook, okay, to understand every node and its performance. The same thing happens in case of a class. This example I gave you. In a class, if I say there are 60 students, I have to track all the performance of all 60 students. In that case, I have to keep a separate notebook for every student. Clustering means what? Same type of students, I am making them a group. And instead of checking single performance, I will be checking group performance in that time. And whoever are the group members, they will be having average performance of the group performance. So clustering actually is done for that. The same type of few nodes are put together in a single cluster, and one cluster head or class monitor is being formed that actually keeps track of all the other nodes within that cluster. So the nodes in Ad-Hoc wireless network or sensor network need to organize themselves into cluster. So few nodes together is making a group. So clustering is nothing but grouping. Clustering allows hierarchical structure to be built on the nodes and enables more efficient use of constrained or scarce network resource. So if we want to reduce power consumption, if we want to reduce unnecessary wastage of bandwidth, in that case, so these things, spectrum, frequency spectrum, bandwidth and node energy, these three things, if we want to save, in that case, clustering becomes a better solution. If cluster size is equal to one hop or sensor node distance, that means there is a sender node at the center and there are receiver node surrounding to it. So that is called as a star kind of a structure. Okay, so one hop distance. The sender node is there at the center and all the receiver nodes are there at the circular periphery. In that case, or star architecture, it becomes very simple to transmit or broadcast data or route the data from the transmitter to the receiver. Exactly the diagram is shown here. Let's take this is a circle kind of a thing. This is a central coordinator node and it wants to send data to every direction for a same radius r. In that case, this will transmit and all these nodes will receive. So this is the easiest or simplest kind of a cluster. Okay, where the main sender node or PAN coordinator or coordinator node is there at the center, and all the receiver nodes are there at the periphery. And receiver nodes are also different types. Okay, so this green receiver nodes are full function device. That means they can transmit for a longer distance, they can receive from a longer distance. But this blue nodes, they are reduced function device. That means all nodes within a cluster are not having equal capability. So one is a coordinator node, he is the master. Few nodes are there, green nodes, they are having maybe high computational capacity, high transmission capacity, but not as much as this red. Red is having highest capacity of all. Transmission, calculation, memory, energy, everything. Green is little less and blue is least. So blue maybe can only transmit to this red. Blue cannot even transmit to the other cluster. Okay, so such few different functionality wala node we are putting together and forming a cluster, and we are putting one main coordinator for that. Okay, so the main sensor node or main body who is actually controlling the whole ad-hoc network, he will be contacting only this red node. So this is exactly the way the country is run. So there is a prime minister, there are chief ministers, there are local MPs, like that. So he is a local MP kind of a thing. Okay, and this blue, green, and all these things, we are the civilians. So this is just part of a big network. Then there can be tree structure. Okay, just see, this is here the main node was at the center and other nodes were there at the periphery. Here it is not like that. So it is a tree kind of a thing. The way the branches in the tree grow, so this is that kind of a structure. So this PAN coordinator can come in between. So from every PAN coordinator, there are 3-4 different branches going, and in every branch there are some small nodes with different capabilities. So this is a tree kind of a structure, and there is a mesh kind of a structure. Okay, so this mesh means everybody can connect to everybody. Here you can check in star topology, every node has to connect to the center only. Okay, but in mesh, every node can connect to everybody. So this is a mesh kind of a topology. So I'm very sure that in CCN you are checking all these different kinds of topologies in the network. Same topologies can be applied for ad hoc network also with some kind of modification. It is saying that same time division or same frequency division multiplexing can be reused across non-overlapping cluster. So one cluster is here which might be transmitting with 1 megahertz frequency. Such same thing is another here. In that case, if here 1 megahertz frequency is used for transmission, this another cluster can also use 1 megahertz for transmission, because there is no direct frequency link between this cluster and this tree cluster. Okay, so frequency reuse, time division reuse, all these things are possible because of clustering. Otherwise, if all these nodes are part of one very big network, in that case the same frequency cannot be used by more than one transmission. Okay, but if clustering is done node wise, zone wise, the same frequency can be used. The same frequency can be used for transmission and reception. So network can be comprised of mixture of nodes, including some nodes that are more powerful. So here red is most powerful, green is little less powerful, and blues are least powerful. So blues are just sensor, it is just sensing and sending the data to the red thing. This green can be sensing and processing and then sending the data to the red PAN coordinator, and this PAN coordinator are talking to the higher authorities. So likewise, so networks can be comprised of mixture of nodes. Every node are powered in a different style. They are powerful in and having different capabilities, such as increased communication range, GPS. These more capable nodes can actually play the role of cluster head. So among the six nodes, red can be the cluster head. So if this cluster has to talk to another cluster, that job will be done by this red node. Okay. Finally, clustering also allows the health of the network to be monitored and misbehaving nodes to be identified. So if there is any node has gone bad, or it is behaving very erratically, that node will be thrown out, and it is possible only if you are using cluster head or proper clustering technique. Okay. So as some nodes in a cluster can play watchdog over the other nodes. So watchdog means it is there just to keep a watch over other nodes. So cluster head can be the watchdog. So here I have shown 4 clusters. So you can check at the center there are CH, that is the cluster head. Okay, the green nodes are very simplest kind of a sensor nodes, and the yellow ones are gateway. Now position of gateway, if you can check, gateway is nothing but at the common position for cluster 1 and cluster 2. So this pink one is cluster 1, this thing is cluster 2. So between cluster 1 and cluster 2 at a common position, this gateway is there. So through gateway node, we are keeping contact or sending data from one cluster to the other cluster. So what is the job here? Job here is the source. So some activity, something is happening here, and that has to be relayed to the destination. So this yellow. So this purple is the source or activity, and that message has to be relayed to the destination node. So for this, it is actually being conducted through three clusters. Okay, so first cluster is monitored by CH1. So there are two types of communication. The black lines, so black line is from cluster to the cluster head to the simple nodes. So this is the black lines. They are not carrying any data here, but the red lines, okay, red dashed lines, dotted lines, they are carrying the information. So here you can check the information is not coming to this gateway, or information is not coming to this way. So what is the information path? Information path is red. So from the source it is going to CH1, from CH1 it is going to gateway 1, gateway 1 to CH2, then maybe gateway 2, then maybe CH4, and then to destination. So this is the path. Okay, because this side in cluster 1 the activity is there, and it has to be taken to cluster 4. Okay, so by means of togetherness, by means of helping each other, the same information is sent from the cluster 1 to cluster 4. So this is a very important diagram. If asked in the exam, how does the mobile network doing the clustering kind of thing? So this diagram you have to explain. You have to tell what is cluster head. So this is the main node inside the network with too much of capability, GPS, higher memory, higher communication range, higher computational power, higher battery power, and all those things. And this activity, so this is the source of information, and these green nodes are just sensing nodes. They can only communicate to the cluster head, but cluster head can communicate. So there between cluster head 1 and cluster head 2, direct communication can also happen. Okay, between this cluster head and cluster head, by bypassing the gateway, there also can happen a direct communication between all the cluster heads. Okay, so data has to be transmitted from cluster 1 to cluster 4. In that case, it sees the source CH1, gateway CH2, gateway CH4, and destination. So by togetherness, or by helping each other, every cluster data can be transmitted from one cluster to the other cluster. So you can check here main types of nodes: cluster head, gateway, and normal sensor node. Main type of communication: one is intra-cluster, one is inter-cluster. So those black lines are intra-cluster, that is happening within the cluster, and these red lines can be inter-cluster. Okay, so here the inter-cluster information has to be exchanged. That's why red line are passing from cluster 1 to cluster 4. This is another two types of clustering I have shown. So this is the first type. This is called tree type. You can check. This is one hop distance. So this is the this is actually for wireless sensor network, not for ad hoc wireless network. Okay, so this is a wireless sensor network clustering. So this is a tree type of structuring. There is a central node, and all the other sensor nodes are there in the periphery. And this is another type of clustering, which is here some 4 different nodes have made one cluster, and this is a little bigger node, which is a cluster head. Here there is a blue, and here there is a green, and then the CH1, CH2, CH3, they can form another cluster. Okay, so like this is one department, this is another department, and this is another department. So there are 3 clusters, and all the departmental heads together, they are forming another cluster, and they are directly talking to the principal of the institute. So here 3 different clusters I have shown: blue, green, and red. And then again CH1, CH2, CH3, they can form another cluster, and they can be talking to the principal. So that is called as hierarchical kind of a clustering. So here are different intra-cluster and inter-cluster things are there. So here it is different types of structures are there. Cannot explain it to you, but just keep this diagram with you at present. In actual time, we will say this. Okay. So what is actually clustering doing? So here you can see this is another type of clustering. So here the same thing I have shown you. So few nodes are forming a cluster. There is a cluster head. Again, few nodes are forming a cluster like this, and this is the cluster of the cluster heads. Okay. So this cluster head is directly talking to this nodes, this cluster head is directly talking to this node, and this cluster is directly talking to this node. There is another type of clustering. So many sensor nodes are forming one bigger cluster. One cluster head is there. So all the information from this is going to the upper tier. So this is the tier 0, tier 1, tier 2. So tier 2 is the maybe prime minister. So this is the prime minister. This is the cluster of all the chief ministers, and then this is the cluster of all the common people, and chief minister is also a part of it. So this is a hierarchical clustering. It is said that nodes that can communicate with two or more cluster heads may become the gateway. Just now I had shown you in the previous diagram, that is this yellow nodes which can talk between two clusters becomes the gateway. This is the important thing. Nodes that can communicate with two or more clusters become the gateway. Nodes that aid in passing traffic from one cluster to the another is called as a gateway. Depending on the position and weights and importance of the node cluster, the gateway is decided. So any node can be a gateway depending on its capability and whether it is positioned in a proper place or not. So clustering can be used to thin out the parts of the network where an excessive number of nodes may be present. Okay, so maybe in one region which is very far from the sender, 3-4 nodes are there, so they cannot directly transmit to the sender node or receiver node. So they will select one cluster head. So they will send all the information to the cluster head, and cluster head will send the information directly to the sender. So that is what it is saying. A simplified long-range communication network can be set up using only the cluster heads and gateways. So the nodes which are sensing, all the nodes after sensing not sending the data to the main base station. So all the nodes, they are sensing the data, they are put in a cluster, they are sending all the data to the local cluster head. Cluster head is processing it little bit, and then cluster head is having a higher communication capacity. This is sending the data to the gateway or to the next cluster. So this way we can save some communication power. So this is another type of protocol we are saying. So clustering or grouping of sensor nodes or combining of sensor nodes in a intelligent way helps in transmission of data in a compact form. So every sensor node is picking up a lot of data. So there are redundancy in all the data. So some data are repeated. So all those data when come to the local cluster head sorts the data, and cluster head remove the redundancies and make the data compact. And then the compact data is transmitted to the next cluster by means of gateway, or to the base station by means of gateway. So this is a very important line. Clustering or grouping of sensor nodes or combining of sensor nodes in an intelligent way helps in transmission of compact data. This not only reduces the global data to be transferred and localized most traffic to within individual cluster, but also reduces the overall data control traffic and hence contention within the network. So if we are transmitting a compact data, that means we are saving a lot of bandwidth, we are saving a lot of energy, and hence by clustering we can save a lot of resources within a network. So this is clustering, and we can ask a short note on clustering. So all the diagrams and all, so this diagram you can draw if short note on clustering is asked, and you have to explain what are the cluster head, what is sensor node, what is gateway, and how the data communication takes place from one cluster to another cluster, and what are the advantages of clustering. That is actually explained in this slide. So this slide is actually the advantages of clustering. Remember that. Before going for multicast kind of protocol, we will tell you what are the different types of casting. So there are mainly three casting. It's a another very important question. It is called unicast, from one sender to one receiver. It is called unicast. Okay, from one sender to many receiver, broadcast. So whatever is happening now, I am telling and you all are listening. This is broadcast, but you can also talk to me. Okay, so one sender to one receiver, unicast. One sender to many receiver, broadcast. Many sender to many receiver, that is actually called as multicast. So one to several. Okay, so one to nearest group, it is called as anycast. So many sender to many receiver, okay, that will be called as a multicast. So you can check here, it is the broadcast kind of a thing. So one is the sender and he is sending and it is going towards every direction. Okay. And here it is multicast, that means from here it can go here, from here it can go here. So broadcast and unicast, multicast, all these things are Right. So unicast is one sender, one receiver. Broadcast is one sender to many receiver. Multicast is one sender, many receiver, and many sender, many receiver. Okay, this is a very important thing. So broadcast is a type of a multicast you can check. So this is a question which is asked very frequently. That is, what is unicast, what is broadcast, what is multicast. So unicast means one sender to one receiver. Broadcast means one sender to many receiver. Multicast means many sender to many receiver. Now, if we are trying to do many sender to many receiver in case of a ad hoc wireless network, then what are the routing protocols we will be following? So I'll just do these two slides. That is the introduction part, and after that I will stop. So let us just do these two slides, and it will be telling you a lot of informations. So design issues we will not do today. At least we will be doing these two slides. So let us see what is meant by multicast routing protocol. Ad-Hoc wireless sensor network has applications in civilian operations, emergency, law enforcement. So many difficult kind of operations it's having. In all these cases, setting up and maintaining the communication infrastructure may be difficult and costly. In all these applications, communication and coordination among all nodes are necessary. Multicast routing protocol play an important role in ad hoc wireless network to provide this communication. So multicast network is actually the backbone of any ad hoc wireless network. It is always advantageous to use multicast network than many unicast network. Okay, that means one sender to many receiver or many sender to many receiver at the same time. So many sender to many receiver or multicast is the best way of saving time, and it's actually adding a dynamic property to the whole network. Because of the dynamic nature of the network topology in ad hoc, IP or internet-based multicast routing protocol here cannot perform well directly, because in ad hoc the dynamically changing topology. So the IP protocol directly cannot be applied to ad hoc, because ad hoc is dynamic changing topology. Ad hoc is having less bandwidth. Ad hoc is having less reliability of link. So ad hoc link can get break at any time. Long convergence time, that is another problem of ad hoc network. So all these problems in ad hoc network we will call long convergence time. Long convergence time means it will take quite a lot of time to transmit the same amount of data packet from the sender to the receiver. So more convergence time means, so if bandwidth becomes less, time for data transmission becomes more. That means it is called more convergence time. So all these three problems, that is dynamically changing topology, less bandwidth, and less reliable link because of dynamic link. Okay, they causes problems of higher convergence time, formation of transient routing loops, means the same data keeps on looping in a network. It doesn't go to the receiver. It starts at one point and again come back to the same point. That is called looping. Consumption of costly bandwidth if IP-based multicast routing are applied to ad hoc networks. So very important paragraph in between. Why IP cannot be used in ad hoc wireless network? Because it will create long convergence time, because it will form loop, and because it will consume unnecessary bandwidth, because it will waste a lot of power. For all these reasons, IP cannot be directly used for ad hoc wireless network. In that case, we have to design a separate protocol, and that is actually multicast protocol. Wired network uses an established routing free for multicast session. Okay, so ad hoc network and wired network, they are different. Here I am talking about wired network, established network. Okay, a packet that is sent to all nodes in tree passes once through each node. That means avoids looping, and each link is a tree. Such a multicast structure is not appropriate for ad hoc network because the tree could easily break due to a highly dynamic topology. That means in case of wired network, a very fixed path is followed always, but that might not act in case of ad hoc wireless network because of mobility. So here the reasons are given this paragraph, so you can go through why wired multicast routing is not directly applicable for ad hoc network. First thing is multicast tree structure are not stable, okay, in case of ad hoc, and it continuously connectivity changes due to mobility. That is the first thing. Maintaining a routine tree for multicast packet forwarding under frequent network topology change generates huge control traffic. That is the problem of ad hoc network, hence bandwidth loss. Frequent exchange of communication link, state tables, and by continuous topology change is excessive control or processing overhead. So all these are actually the property of wired multicast routing. Okay, but they cannot be directly used for wireless multicast routing. So this is another very important question, that why wired multicast routing protocol is not directly applicable for ad hoc wireless network. Longer period for routing, because in wired long tables are created. Those tables take a lot of time for transmission. Okay, but that cannot happen in case of ad hoc network, because in ad hoc network it has to happen very fast. Therefore, multicast protocol used in static wired networks are not suitable for ad hoc network. Okay. The multicast routing problem, the problem of determining which nodes in the network should participate for targeting of multicast data packet. That means which node should be a part of data routing between transmitter and receiver is the main challenge in case of multicast routing protocol, and presents several multicast routing protocol for ad hoc wireless network. So the main issue is which nodes will be a part of the ad hoc network routing protocol, and which network might not be a part of ad hoc network routing protocol. So I stop here. We'll start with the multicast routing protocol design issues in the next day. Thank you.